This is 4.7a of algebra. So a sequence is an ordered list of numbers that often form a pattern, and each number in that sequence is called a term. So we can look at these lists of numbers and figure out what the pattern is. Either we're going to be adding a number each time, or subtracting a number each time, or multiplying by a number each time. So let's look at A. I've got 5, 11, 17, 23. So from 5 to 11, I add 6. And 11 to 17, I add 6. And to 23, I add 6. And I'll figure out the next two terms. So 23 plus 6, that's 29. 29 plus 6, that's 35. And then let's try B. 400, 200, 100, 50. So let's say I'm looking at this and I go, oh, well, from 400 to 200, that's subtracting 200. And then from 200 to 100, well, that's subtracting 100. No deal. Can't be like that. It has to be the same each time. So if it's not subtraction, then try out division. Well, 400 divided by 2 gives me 200. And 200 divided by 2 gives me 100. And 100 divided by 2 gives me 50. And I ran out of room there, but my next term, 50 divided by 2 would be 25. And 25 divided by 2 would be 12.5. The other one I want to look at here is C. I've got 2, negative 4, 8, negative 16. How do I get from 2 to 4? Well, multiplying, ignore the negative for a second. To get from 2 to 4, I'd multiply by 2, right? And 4 to 8, I'd multiply by 2. And 8 to 16, I'd multiply by 2. But each time, it's changing from a positive to a negative. If it's changing from a positive to a negative, you're multiplying by a negative number. All of these, I'm multiplying by negative 2. 2 times negative 2 is negative 4. A negative times a negative, negative 4 times negative 2, gives me a positive 8. 8 times negative 2 gives me negative 16. So my next one would be negative times a negative, it's going to be a positive, so 32. And after that, I'd get negative 64. Okay, an arithmetic sequence, here's an easier way to put it. An arithmetic sequence is when you're adding or you're subtracting. And how much we add and subtract by is called the common difference. So, we're going to check if these are arithmetic or not. So, A, 8, 15, 22, 30. From 8 to 15, I add 7. 15 to 22, I add 7. 22 to 30, I add 8. It is not arithmetic. It does not stay the same. Not arithmetic. Why don't we try B? 7, 9, 11, 13. 7 to 9, I add 2. 9 to 11, I add 2. 11 to 13, I add 2. So this is arithmetic. And my common difference is 2. If I was subtracting 2 each time, I'd say my common difference is negative 2. Okay, a recursive formula is a formula where we need the term before it. We've used equations so far where we plug in a number and we get the answer. So we could plug in 50 and we get the answer. Well, if we're working with a sequence and we're working with a recursive formula, if you want to find the 50th term, you need to find the 49th term. And to find that 49th term, you need to have the 48th term. And to find the 48th term, you need the 47th term, etc. So you can't just plug in 50 and get your answer out. When we're working with a recursive formula, you need to know what came before it. So let's write a recursive formula. Let's try out A, 3, 9, 15, 21. So from 3 to 9, I'm adding 6. 9 to 15, I'm adding 6. 15 to 21, I'm adding 6. So this is arithmetic, and my common difference is 6. So when we're writing a recursive formula, we need to give the very first term. We need to have a starting place. So A of 1 is my first term. It's like function notation, okay? I'm plugging in 1. So this means first term. Oops. First term. And my first term here is 3. And then I want to find the nth term. I want to give a generic equation. So this is for the nth term. And to figure out, like, let's say to figure out the 100th term, I need to know the term before it. So that'd be the 99th term, right? So if I'm finding the 100th term, I would plug in 100 here. And the term before it would be the 99th term. So you're subtracting 1, right? You did 100 minus 1, that gives you 99. So I'm going to do A of n minus 1. This is the term that comes right before it. So it'd be A of n minus 1, then we'd have A of n, then we'd have A of n plus 1, A of n plus 2. And then we take our previous term, and like, how did we get from 3 to 9? Well, I added 6. And how did I get from 3 to 15? I added 6. So you take the previous term and you add 6. So here's what our generic equation would look like. Oops. We list our first term. Let's do it this way. Equals some number. That number there is our first term. And then you always have A of n equals A of n minus 1 plus or minus your difference, how much you're going up by each time or how much you're going down by each time. So when you are writing this, every single time, this will be the same. You change this number, and you change this plus or minus number. So let's say it's going down by 2, it'd be minus 2. It's going up by 10, it'd be plus 10. So let's try one more. We'll try that term B there, or that example B there. So it's going up by 12. Going up by 12, going up by 12. So first I need to have that A of 1 equals, what was my first term there? 23. The first number listed is 23. And then I'll have A of n equals A of n minus 1. And then my difference was adding 12 each time, so plus 12. And that right there would be my recursive formula. That's all I have to do. Just find it. You don't have to solve it. You don't have to move things. That would be my answer. There's your homework.